Hi, I'm Onur Tepençelik and this is my term project for EEE474. In this project, I explored the effects of MRI sequence parameters on image reconstruction. I will demonstrate different weightings on the image object, such as T1 weighting, T2 weighting, and proton density weighting. I will also show the effect of resolution and field of view on the reconstructed image. First, an object consisting of 5 different tissues is created and imaged using the 2D Fourier transform imaging method. These tissues are water, muscle, liver, fat, and protein, respectively. The object is created as a matrix in MATLAB which holds the T1, T2, and relative proton density constants for each tissue. Here, we can see the visualizations of these T1, T2, and PD layers. I started by making a T1 weighted reconstruction. To eliminate the effect of T2 relaxation, I set the echo time to a very low value, 20 milliseconds. To give the emphasis on T1 relaxation, I set the relaxation repetition time, TR, to a comparable value to the T1 constants of the tissues, 500 milliseconds. It can be seen that the signal intensity of fat tissues is the highest. This is expected because the T1 constants of the fat tissues are lower than others, which means that fat tissues are able to recover quickly after the excitation, whereas other tissues cannot recover their longitudinal magnetizations as much. For example, water has much lower signal intensity because it has the highest T1 constant. On the other hand, although proteins have a T1 constant equal to that of fat tissues, their signal intensity is very low because of their extremely low T2 value. The signal coming from the proteins decays immediately because of the small T2, and proteins are going to appear darker no matter where is the emphasis on the imaging. Similarly, I made a T2 weighted reconstruction seen below. This time I set TR to a very high value, 5000 milliseconds, to eliminate the effect of T1 relaxation, and set TE to a comparable value to the T2 constants of the tissues, 50 milliseconds. In the below image, water has the highest signal intensity as opposed to the above image. This is because water has the highest T2 constant, meaning that it takes a long time for the signal coming from water to decay. Muscle and liver have lower T2 constants, therefore their signals decay faster compared to water and fat. As I said before, the signal coming from protein decays immediately, so it appears dark on the image. I continued by a proton density weighted image. In order to eliminate the effects of both T1 and T2 relaxations, I set TE to a very low value, 20 milliseconds, and TR to a very large value, 5000 milliseconds. It can be seen that the signal intensities of the tissues are proportional to their proton densities, water and fat having the most intense signals, followed by muscle and liver. After observing the effects of sequence parameters, I tried to change the resolution value. We have seen the T1 weighted reconstruction with a resolution of 1 mm, which is the maximum possible in the MATLAB environment as we are taking one sample for each pixel. I tried to reconstruct the image with the same T1 weighted sequence, but with lower resolution, 2 mm and 4 mm. It can be noticed that there are discontinuities in the x direction. This is because the scanning is done in x direction and the decrease in the number of samples causes a worse reconstruction. The change in the case space representation is also noticeable, as it is clearly seen that the amount of information is decreased with less number of samples. Finally, I played with the field of views of the reconstructed images. The figures show the reconstructed images with half of the spatial field of views in x and y directions respectively. We can notice that the reconstructed images are stretched along the direction in which we decreased the FOV. This is because the FOV is inversely proportional with the distance between consecutive samples. Also note that in the below figure, we see an effect of low resolution similar to what we saw in low resolution reconstructions. This is because when we increase the distance between the samples in the scanning direction, we lose some of the information. The case space representation is similar as well. There are a lot of parameters that affect the result of 2DFT image reconstruction. It is worth noting that most of these parameters have an effect on the imaging time in real life, which creates a trade-off with image quality. Increasing TR is just a mathematical operation in MATLAB, however it directly affects the total scanning time in real life, so it could be harder to eliminate the effect of T1 relaxation in real life. Decreasing the resolution or the field of view may result in a lower quality image, however they gain on the imaging time, both in real life and in MATLAB. Sometimes a faster imaging may be needed, therefore one may consider giving up on a high resolution image to obtain immediate results. The parameters should be adjusted according to the requirements of the imaging task. Thank you for watching.